I just told you guys, never write, never learn or never say K Q1 Q2 by R square. Try to habit this. Always 1 upon 4 pi epsilon naught Q1 Q2 by R square. So putting the values, this whole becomes 9 into 10 raised to power 9, Q1 10 raised to power minus 6, Q2 3 into 10 raised to power minus 6 upon distance square 9 into 10 raised to power minus 4, exactly R square. So 3 into 10 raised to power minus 2 whole square becomes 9 into 10 raised to power 10 raised to power minus 6 raised to power 2, that is 10 raised to power minus 6 whole square is 10 raised to power minus 12. It is not equal to 10 raised to power minus 36. No. Power gets multiplied. So I was here 9 to 10 raised to power minus 4. 3 into 10 raised to power 9 minus 6 minus 6, 9 minus 6 minus 6, this negative comes up and becomes plus 4, 9 plus 4 13, 13 minus 12 1, 3 into 10 raised to power 1, that means 3 into 10, that means 30 newtons. You have just found the value of Fa. Okay, the direction of Fa was represented very well in the diagram. So you are not supposed to write this in vector form. You have to just write the formula, give the value, that is all, nothing more in the numerical. While finding out FB, for FB, Q1 remains same, Q2 is minus 3 into 10 raised to power minus 6, R is 3 into 10 raised to power minus 2, same distance. So the formula becomes, again you write down the formula and put the values, but I have done some mistake here. Figure it out. There is something wrong here while doing right now. I am writing what? FB. The wrong part is I am not supposed to take the negative sign in the numericals, because remember the sentence I gave you during the vector form of Coulomb's law? The force of interaction between charges separated by this, and the direction of force is given by nature of charges. Like charges repel each other, unlike charges attract each other. So here I am not supposed to take the negative sign, because this negative sign has done its part. It has given us the direction of force which is vertically inwards for this charge, like it's inwards towards B side. That is all. You don't have to take the sign. So remember this thing. Never take sign in all those numericals where there is vector form included. For example, electric force, electric field. Never take the sign of the charge. This will again be equal to 30 Newton because everything was same. Remember, we are doing first topic, like first type, how we could solve it. So what would be the answer? I have got Fa, I have got Fv. Fa and Fv are in their respective direction as shown in figure. So what is the net force? Always use the resultant formula. Net force would be, as this principle states, vector sum. Vector sum would be finding resultant, that is Fa square plus Fv square plus 2 Fa Fv cos of theta. What is theta here? What is the angle between these two forces? Right now it is 120 degree. How? It was equilateral triangle, this was 60 degree, the whole thing is 180, that means that is 120. What is cos 120? Cos 120 is minus 1 by 2. If you have doubt how to find the values of cos 120, tan 300, sin 300, I'll tell you a technique. But first let's finish it off. Under root 30 square plus 30 square plus 2 into 30 into 30 cos 120 is minus 1 by 2. This 2 cancels out, this negative sign. Do not open the square right now. Try to keep it as simple as possible. 30 square plus 30 square with a negative sign minus 30 square. You're left with under root 30 square, that will give you 30 Newton. So that is the net force, and where will I draw? Between these two forces. This is FAB, that is net force due to A and B. This was one of the method of doing such kind of question. What is the other method? The easier one. The easier method is finding the components. We did it in +1 vectors. Let's just recapitulate what we did. The diagram is a bit messy. I'm rubbing it and I'll redraw it. Recapitulate what we did in vectors +1. What were the basic laws? How do we make components? Making component is very simple. This is vector A at an angle theta with the horizontal. I've met with many students who always have doubt which one to be taken cos, which one to be taken sine. I'll not go into that detail right now. That will be covered in maths part. I'll give you a very simple formula. Where there is theta, there is cos. Where there is theta, there is cos. That means this is theta, so this automatically becomes cos component. A cos theta, the other will be sine theta. Cos theta is always there where theta is there. So that is the method of taking components. Remember the answer what we did? We just did a numerical. The net answer was 30 newtons. See, I'm redrawing my diagram. A bit smaller though. 3 centimeter. What were the charges? 1 microcoulomb, 3 microcoulomb, minus 3 microcoulomb, right? Even if I have taken some wrong value, do it correctly later on. But for now, see the components. A, B. This is the direction of force due to particle at A. Take x and y axis here. This angle is 60. That means this angle would also be 60. As I just told you, where there is theta, there is cos. So which will be the cos component? This one. This is FA cos 60. This will be FA sin 60. Right? What about this? The other one. This minus 3 coulomb will attract. Will I make any component of this force? Will I or should I? FB. This was the point B. See, while making components, we always draw the x and y axis first. Then what do? We see at what angle our given vector is, and then we take the angle and then we take the cos component. If it is x, this one becomes x cos theta. But what if the vector is already on a y axis or x axis? Then you don't draw the component. Simple, that is the net thing. After that, what you have to find? Once these components are made, find fx, that is the net force along x axis, and find fy, that is the net force along y axis. After finding fx and fy, same apply the resultant formula. Now in this case, it will look quite time consuming, and even though problematic, or you would find it more difficult than my previous method. But I'll tell you, taking components and solving the numericals is always easier than the other part. Not in this case, because the question is quite simple, but there are very random cases. I'll just go to that point as well. Suppose you have, this is your wall. This wall is like this, 90-degree wall, like that corner, and this thing was given some charge. So this whole wall have some positive charge. We had a ball hanging, a pith ball hanging from the wall vertically, but due to this charge and the charge present on the ball, this ball got repelled. So the new diagram of this is actually like this. The new diagram is this now. What are the forces acting on this ball right now? Number one, the force of repulsion. This is electrostatic force of repulsion. Number two, the weight, which is equal to mg. Number three, the tensional force, the tensional T in the thread. So in this case, are you guys going to apply the Lamby's theorem? Do you remember Lamby's theorem? X upon sin x plus y upon sin y equal to z upon sin z. Alright, don't forget it. Are you guys going to do the net resultant? Finding resultant is how will we proceed to that finding resultant? We have to find resultant of this and this first. It will be somewhere here, and then we'll find the resultant of this tensional force and the resultant of electric and this gravitational force. Instead of doing all that, simpler form is take the component of t. Let this angle be theta. That means this angle would be theta. This will become t cos theta, and this will become t sin theta. Now, since the ball is in equilibrium, equalize the forces, whatever the balancing forces are. So that will give me mg is equal to t cos of theta, and electrostatic force is t sin theta. From this equation, take out the value of t, put it in other equation, find the value of f. Simple. So in these kind of questions, taking components is always easier. In that kind of questions, finding the resultant is always easier. So adjust your thinking process accordingly. Yes, if you guys are familiar with this kind of question, this has came quite a times in board exams. Let's go back to that part. We'll finish it off fast and we'll move on. Here, net force along x-axis is, there are two forces which are acting right now along x-axis. One is Fa cos 60 and one is Fv. If I numerically calculate the value of Fv, that will give me 30 newtons. But if I numerically calculate the value of Fa cos 60, Fa was how much? Again 30 Newton, yeah, exactly. Fa cos 60, Fa was 30, cos 60 is 1 by 2, 15. So net force, there are two forces acting on, suppose this charge on left side. This force is 15 newtons, and on this side this force is 30 newton. Where is this charge supposed to move? Along the 30 newton, along the greater force. So net force along x-axis would be Fv minus Fa cos 60. I have taken Fv minus Fa cos 60, not Fa cos 60 minus Fv, because this was greater. Simplify it, just subtract the smaller value from the bigger value. So Fv minus Fa cos 60. And in case of Fy, vertical forces is only one, Fa sin 60, which is Fa sin 60. Fa sin 60 is what? Fa was 30, sin 60 is root 3 by 2. What we get? 15 root 3 newtons. Here we have 30 minus 30. 30 minus 15. So we have got 50 newtons. We have Fx, we have Fy. So the resultant should be equal to the answer what we obtained previously. The net answer would be under root Fx square plus Fy square. Where is this formula coming from? Why I am not using that formula, under root Fx square plus Fy square plus 2 Fx Fy cos theta? Why am I not using this formula? Because I am using this formula only, but in case of x and y, they are perpendicular to each other. So this thing cos 90, theta becomes 90, cos 90 is 0, the whole term vanishes. That is why. So under root Fx square plus Fy square means 15 square plus 15 root 3 square. What is 15 square? 15 root 3, sorry. What is 15 square? 225 plus what? 225 into root 3 square 3. Multiply and add, it will become 225 plus 15, 3, 6, 7, 6, 675 plus 225, 10, 7, 8, 9, 10, 6, 7, 8, 9, under root 900 is 30. So end result is same. No matter what type of method you are following, personally I would suggest try to do as many components question as you can.